Okay, so when we talk about robots, we're really talking about the possibility of using machinery. We are human beings, we are continuously improving ourselves. We're trying to become more beautiful, like Marilyn Monroe here, we are trying to become more efficient, more economic, more optimized. So we are developing all these prosthetics that are actually happening and helping us to become better, and robots are one part of that. Now, some of the robots that are actually fairly attractive have been in science fiction for the last 15 and 20 years. So they can be humanoids, they can replace us, they can compete with us. People are actually quite scared because they're thinking that robot labor will replace what human labor has been done so far, and the prognosis is not entirely looking too good because all the admin stuff will be replaced. But there's lots of other things that we can do with these robots in order to make this world a little bit of a better place. Robots have been introduced in fashion for design processes, which is one of the topics that I want to take you through today. Alexander McQueen here in the fashion show, that's a bridal dress that's spray painted and that's customized with 2 robots while the dress is being rotated. Stellar uses this here in order to write the word evolution with a second or third hand that replaces the mechanics of their choreography, which is really fairly complicated in order to translate towards robotic terms in order to write. Not easy to do with the robot himself. Everybody knows Tony Stark, yeah? Weaponry is one of the things that robots can produce, but what we're also looking at here is this robot is not only a weapon, it's an armor, and it's also a sort of best friend. So with that image already we are going into social robotics, the human intelligence that accompanies the way that we're living with today. But do people know what a robot actually does? Do you know how the system works? I wasn't really sure that you would do that. So what we're looking at here is a change that happens from automated fabrication processes that have been in the industry for approximately 20 years, robots building our cars together, towards a proper understanding of what the robot actually does. So a robot as such is just a machinery that's super blind, it's dumb, and it needs to learn all the different processes. So it stays within a particular work envelope, as we do see here. It's almost like a Captain Hook. So this one here is one without the end effector. So any tool that you put onto the robot will help you to go into fabrication that's 6-axis. So it's a very universal tool that allows us to undertake different work processes depending on the machine that you're actually putting on these industrial arms. So with a simple tool that's, for example, a drill, everybody knows how we're working with that, yeah? You can cut into styrofoam, you can cut into plaster, you can make solids, you can make these voids, you can cut so that you can actually put up a catenary structure, you can work inside a work envelope, and you can construct that same work envelope as well. ETH has been using these processes on a linear track, which expands the workspace of the robot in order to produce actually quite interesting designs. Here, a bricklaying structure. We have been continuing to work with that in the space of fuzzy modules, where we're actually looking at timber constructions that are highly contextualized depending on the availability of the wooden materials in the assembly process, and highly responsive towards the environment in which the robot is actually working. So that's a sort of very brief overview. Something that changes in the building industry from automated processes and completely defined robotic protocols towards explorative design processes and facts. So this one here is a mid-air deposition of a structural component that may help you to produce doubly curvilinear forms in space. So this is sort of structural reinforcement in concrete walls. That's completely dependent on interactive with the collaboration in terms of a sort of moving platform underneath and the form that's being determined in the process itself. There's also a possibility to work with multi-agent systems, again, like a structural approach that helps you to register with the Connect sensors, the deposition, and thus produce these large cantilevers. So you basically have a data protocol that builds up by information of sensing towards the actual execution of the process itself. What we also had was more material tests in terms of developing new technologies here in the sense of custom sewing of timber timber veneer structures, which actually can be moved into a shingle system, this making this interior spatial divider walls, or going into a feedback data system between program language, robot execution, and the data structure, where sensors actually test the lights and densities in terms of clay printing here and punching of these robotic structures, and enable us to do a very different understanding of how we're actually dealing with a very traditional material such as clay. So we have the possibility here where the designer is directly working with the data in order to impact these different patterns. Why these patterns are important, I'll just show you in a second. So we continued these structures in a very small workshop, and one of the things that came out of that is that we actually can produce modules that are rethinking brick structures, like the oldest building material, in terms of structural performance. So we would have the possibility to look at 1,000 different bricks, which could be robotically deposited and incrementally strengthened in the interior, in their inner core, depending on the structure of the walls where they're actually sitting. So they can all be unique and participate in this larger whole in terms of their structural performance. And then, of course, as part of that, the Bob Arc 2016, we had also audience participation, so you could get your head scanned and robotically cut within a space of 5 minutes, which was fantastic. Good. Now we continue into the second section, why we do find this so extremely interesting. One is that we do have all these new material explorations. The other thing is, and this is why I wanted to present that here, we can actually build a very different sustainable future by looking at how we deal with sound and how we deal with acoustic performance. We're at the moment all moving in spaces which are acoustically amplified. I could basically talk to you all without this microphone here, so we just do have that for the film. But it's something that's interesting because if we're taking acoustics as a sort of well-being into the equation, if we take acoustics as something that doesn't really have this large energy consumption, then we do have the possibility to actually provide a better way of how we're speaking to each other, how we're creating communities, and how we are literally dealing with our energy trajectory. So what I'm really interested in is also the capacity of robots to move from the pure design and scripting space that we do have developed in architecture with very highly and very proficient design systems towards the digital and advanced manufacturing that we do have. So there's a proper link between the architecture, the structural behavior, the acoustic behavior, and the advanced manufacturing and robotic fabrication behavior. In order to illustrate that, what we do have here is something that would be perfect from a structural point of view. So 6 tons of snow on a building would lead you to a form that is a sphere. But what you see on the right-hand side, if we do have a sphere, we can't really make that into a community center because it has all these sort of white noise in which people can't communicate with each other. We took that as a possibility to look into a robotic fabrication and a prototype testing of a 1-to-4 component that literally could become that space, with an intersection that starts with a MATLAB equation and looks at 3 different ellipsoids. If you speak into these ellipsoids, the sound is actually being thrown back. If you change these ellipsoids to all be different from each other, you have 3 different sounds that are being reflected back to you. So if you have 3 people speaking into these 3 different ellipsoids, sorry, it's a bit of a conceptual game, I know, but that's just a sort of a possibility. You would have a trichord. So you would have almost a space that works like an instrument in which a community could actually take space. So it's not that interesting because we all want to bring these things out into the real world. So we tested these patterns here, which are basically a pure hexagonal pattern, and that's then deformed by different attractor points, juxtaposed with a flower pattern, which actually proved to be much more interesting. So we sent that with our acousticians through a reverberation room. What you see here is that the sound is actually being reflected much better by the flower pattern. We translated that into an acoustic profile of approximately 350 facets that are possible to throw the sound back in space into different directions. And this is basically here robotic carving that then can be scaled up as well. So if that was implemented in a larger space, it would basically act as a sort of acoustic chandelier that gives you the possibility to completely direct the sound of the space in which you are living. Which is interesting because at that point, we're not really talking about retrofitting an architecture with acoustics as a sort of glance after the fact, but we do have the possibility to work directly with structural engineers and architects in order to make these acoustic performances. So there's a very nice workflow that is now available through robotics as multiple, multi-tool and multi-axis machines that take us straight from design programming in a computational environment towards heavily working with different interdisciplinary collaborations and specialists in their respective fields, and then to move straight into advanced manufacturing. That basically also means that we're working straight with the code of the DNA. We're not working much more with types or with forms, but we're working with formal tendencies. We're working with things that can be changed through the designer within the process. So instead of making a simple drawing with a robot, you can do 1,000 drawings within that same DNA pattern code that is being executed by the robot itself. With what are the future trends for the building industry? Because of course this acoustic performance is just a very, very small section of the area that other people are also working in at this particular stage. So what we're looking at is this one here, yeah? So we're looking at social robotics. We're looking at robots actually not being used for advanced manufacturing, but they're actually used as a direct partner for dancing. And I'm not entirely sure this is where we want to go with the robots, right? Because we want to dance with each other. Yeah? We don't really need anyone else for that. But what we might need these robots for is in order to help us execute things that, with people that are not completely trained into using the manufacturing processes. So we have the capacity now to, with sensor control and voice control, to equip robots with the prompts, voice-speaking prompts that allow us to work directly and immediately with them. So this one here was also a presentation at the Robots in Architecture. Pick the yellow block and put it on the blue block, for example. Or we do have the possibility to use robots which are linked to app tools so that you would be able to work in remote locations. So make a drawing on your app and then the robot 500 kilometers from here would be able to translate that into a drawing. We would be able, if we expand the robot towards working with drones, to make big structural walkways, for example, like this flying bridge here that's built as a steel cable structure by ETH, in order to, again, work in environments where we wouldn't be able to put down a foundation itself. There's new advances with the robots where we do have the Yumi. That's one of the first, as is the EVA, is one of the first dual robots. Yeah? So we can do work processes that are much closer towards using our two arms. Yeah? Very heavily complicated structures, also not so simple to programming, but they have developed some really good interfaces for that. We can look at building processes that are incomplete by just simply judging the material that's available, scanning that material, running an internal analysis, and then using an assembly for that. We can look at very complicated forms that are being produced by sheet materials. We can produce nodal joints and intersections for larger stadia or large span trusses by working with dual robots, for example. We can look at very cheap possibilities of producing very complex formworks, for example, for concrete panels, or to work directly with age-old materials like sandstone. And we do have the possibilities to come from the design generation towards, as I said, the structural analysis, towards going into this slightly smaller modules that are interconnecting and intersecting with each other in order to produce geometries that would not have been available to us in the past 10 years as a direct process from design towards manufacturing. And I would like to leave you with this particular point here. So we do have the advanced robots, but of course that's not an isolated game. Yeah, it changes the face of additive manufacturing. It requires horizontal and vertical integration, so we do have here. There's a possibility to, if these robots are equipped with sensors, to really go into collaborative human-machine environments or augmented reality. We do have the possibility for simulation, and we do have the possibility to change the internet, because these robots are available, they're reliable, they're usable, they can help us build our skilled labors, yeah? And that would also allow us to go decentralized from huge manufacturing towards 2 people and a robot that can execute very many different work processes, and in doing so bring forward the Australian building industry. Thank you very much.